We are going to take a further look at the vertex form of a quadratic relation. Okay, so we said that there are three different forms of the equation of a quadratic relation. One of those is vertex form. The vertex form of an equation, the general form of the quadratic equation, looks like this. So y equals a multiplied by x minus h squared plus k. All right, so in the previous video, we looked at an example of that with numbers. We are going to take a look at what each of these variables does to the parabola in terms of transformations. Okay, so obviously x and y, those are the coordinates on our axis, right? The x value, we can plug in any number and then we can figure out what the y value is, similar to what we did in the previous video with figuring out our table of values. But in a vertex form equation, when it's actually given to you as a real example, you'll have a number for A, a number for H, and a number for K. And we want to take a look at what each of those do to the parabola. So if I look on Desmos, I'm going to kind of walk through the activity that you're going to do on Desmos. So if you're having trouble navigating it, you can see how to do that on your own. So if I switch over to Desmos here, you can see that I've already have plotted y equals a bracket x minus h squared plus k, and it's giving me a little warning sign here, so that's fine. That's what I want to have happen. And you see it's prompting me to add sliders a, h, k. I'm going to click on the button that says all, and I'm going to put in, it'll give me a slider to change the value of all of my variables. Okay, so you can see then it gives me that red curve. Yours might be a different color, that's fine. And I'm going to just bring h to 0 and k to 0 for the time being. Because the first thing we're going to look at is the a value. Okay, so I'm going to zoom out a bit in the graph here. We can see that right now, when I have a is 1 and h and k are 0, this is the parent function, just y equals x squared. My x-intercept, my y-intercept, and my vertex are all at 0, 0, which I can confirm just by clicking on the curve here. You see it will highlight this point 0, 0 for me in gray. And what I'm going to do now is I'm going to just move my a value. I'm going to slide this slider up, and I can see my curve is getting thinner. It's kind of being squished together. And I can, I can move this down. I can see it's getting wider. Okay, and then if my a value becomes negative here, all of a sudden, well, my curve is opening down now. Okay, and then it's either getting smushed closer. Okay, so you can kind of see what's happening here. You play around with it. It's both smushing and widening, and then flipping up, down. Okay, so we want to see what specifically is happening here that's making that occur. Okay, so right now it's at 0, so it's not even making a curve. But if I put this, if my numbers here are between 0 and 1, so here I've got 0.1, it's pretty wide, then 0.2, it's going to become thinner. Each little tick here, I go closer to 1, it gets thinner and thinner. Then as I go above 1, it's getting much thinner, right? My slider only goes to 10, but you can see here that it's quite squished. And then if I go back down to a equals 0, you see it's getting wider, wider, wider. And as soon as my a value goes negative, then my curve is opening down. Okay, so you would have played around with that a little bit more in your investigation, but we can say two things about what the number in front of the brackets, the a value, is doing. So the first thing we can note is that if a is positive, okay, so a is greater than 0, my curve is opening up, okay, like this. So that's kind of a bad diagram. I'll do that again. Opening up like this. If a is negative, Okay, so if a is less than 0, then my curve is opening down, okay, like this. We also saw that when a is a decimal number, it doesn't show it to us as a fraction, but we saw when it was a decimal number, the graph was getting wider. That's the same with it if it was a negative decimal number. And if it's a whole number, then it was getting skinnier. Okay, so kind of just the general way that we will describe this is we are going to say that the graph has a vertical stretch by a factor of a. Okay, so we'll look at some examples with actual numbers in a little bit, but we could say, like, if a was 4, we can say it has a vertical stretch by a factor of 4. If it is, like, let's say negative 1/2, we would say it has a vertical stretch by a factor of 1/2. Okay, we don't need to say that it's negative 1/2 because the negative determines the direction of opening. Depending on your teacher and kind of how they describe it, you may have heard it described as a horizontal a vertical compression. In this case, we're just going to talk about it as a vertical stretch. In grade 11, you'll look more at compression versus stretch and what that entails. But for the sake of just communicating things easier, we're going to just always call it a vertical stretch by a factor of whatever your A value is. And it's always going to be like the positive version of A. Okay, we'll look at some actual examples with numbers in a little bit. But that's what the A value, the number in the A position, is going to tell us. It tells us two things. It tells us if the curve is opening up or down. Okay, so positive is up, negative is down. And it tells us what the vertical stretch factor is. Okay, so if A is 1, then there is no vertical stretch factor because we wouldn't even see a number written there. But if there's a number in front, like if it looked like this, let's say if we had, for example, y equals 2 x plus 3 squared minus 1. Let's say this, we could say, has a vertical stretch by a factor of 2. So now we're going to look and see what effect the number inside the brackets has, so the h value here. Okay, so I'm going to go back to Desmos. I'm going to put my a value back to 1, just so everything is kind of back at the starting point. And I'm going to move my h value around. Okay, so again, my curve now is back to the parent function. Everything, the x-intercept, y-intercept, and vertex are at 0, 0. If I move my h slider so that h is a number that's bigger than 1, we see that my parabola is sliding over to the right. If I bring it back down to 0, it comes back to the origin. And if I move it to a negative value, then it's moving to the left. Okay, so h is moving the curve left or right along the x-axis. Okay, so I can say that the effect of the number inside the bracket, my h value, is it causes a horizontal shift. Okay, so it's either going this way or this way, right? Horizontal is left to right along the x-axis. Now, the thing to note here is, so we saw with the slider, if h is bigger than 0, okay, so h is positive, then it is moving to the right. And if h is less than 0, then it's moving to the left. Now, the thing to note here is because my base equation has x minus h, when we are looking at an actual example, so if I use the same example as before, so y equals 2, x plus 3 squared, subtract 1. In this case, because it's x minus h, this would mean that h is actually negative 3. So this would be shifting, I'm going to say horizontal shift. I'm just going to call it an h shift. So I have room 3 units left. Okay, so kind of the way that I always describe it, I always say your x lies. So when you are reading the number out of here, this shows x plus 3, but your h value is not plus 3, your h value is negative 3. Okay, so your x lies, you flip the sign when you're reading it out of here. So if it said in the equation x minus 3, h would be positive 3 because it's x minus h. So when you're making this equation, if you had x minus negative 3, it would just turn to x plus 3. So that's what's happening there. Okay, so you need to remember when you're reading the h value out, your x lies, you flip the sign, and that's how you decide. Okay, that's the most common mistake is like looking at this and saying, oh, it's moving 3 units to the right because this is positive. But again, h is not actually positive, it's negative 3. So this would be saying there's a horizontal shift 3 units to the left. Okay. Again, we'll look at some more examples practicing with different numbers, but that's something key to make sure that you note because it is a very, very common mistake that I see. We are now going to look at what the k value does. Okay, so the k value is outside of the brackets. It is here. We see it's like a plus k on the end here, and we're going to see what effect that has on the curve. So if I go back to Desmos, I am setting my h value at 0 again. This will move for me. There we go. And I'm going to play around with the k value here. So right now it's at 0. Again, I have my parent function. I'm going to make my k value bigger than 0, and I can see my parabola is moving up. If I bring it back to 0, it's sliding back down. And if I make the k value negative, then my curve is moving down. Okay, it may look like the curve is like getting thinner or wider, but it's not actually. I'm going to zoom out here so you can see it's just sliding up and down. And so when we don't see parts of it, it might look like it's getting thinner or wider, but we're just seeing more of it. Okay, so when my k value is bigger than 0, the curve is moving up. You can see here k is 10, and if I were to look at my if I look at the curve here, then my vertex is at 10. And if I move this down, like negative 10, you can see now my vertex is at negative 10. Okay, so the k value, the effect that this has, is it determines what the vertical shift is. So this is similar to when we looked at linear relations. So vertical shift is either going up or down. Okay, and so when k is bigger than 0, when k is positive, then it's going to move up. And when k is negative or less than 0, it's going to move down. And in this case, k, nothing lies about that. It's just, if it's a plus k, it's moving up. If it's a negative k, it's moving down. It's just that h value that you need to worry about flipping the sign for. So if I look again at the same example, I have y equals 2, x plus 3 squared minus 1. My k value is negative 1, that number at the end there. So I would say there's a vertical shift 1 unit down. Okay, so typically we have a combination of these things happening. So obviously in my example, I kind of just listed them one at a time, but I have a vertical stretch, I have a horizontal shift, and I also have a vertical shift. So we're going to look at an example with some other numbers and describe what we think would be happening on our graph in terms of transformations. Okay, so if I wanted to describe what the parabola y equals negative 2 times x minus 3 squared plus 8 would look like on a graph, I'm going to remember that this is what the generic formula for vertex form looks like. So x minus h squared plus k. And then I'm just going to move this out of the way so we can pick out what each piece of the equation looks like or is telling us. Okay, so here, this is my a value. Okay, so a is -2. And if we recall, we said that a tells us two things. It tells us if the graph is opening up or down, and it also tells us what the vertical stretch factor is. Okay, so here, the negative there is telling us that it opens down. Okay, so negative a says that the parabola opens down. And the a value, I'm going to write it like this. If we look at the absolute value of a, meaning just the positive value of it, that tells us our vertical stretch factor. Okay, so this has a vertical stretch by a factor of 2. Okay, so you don't need to write -2 because we already addressed the negative when we're saying that the parabola is opening down. So the vertical stretch factor is just by a factor of 2. If I look at this piece here, we know that this is going to be x minus h. Okay, so again, your x lies. So this is not h equals -3. This is h equals 3. Okay, so h equaling 3, a positive 3, tells us that there is a horizontal shift 3 units to the right. Okay, so h is positive, so it's going to the right. And the last thing we're going to look at is the k value. Again, this one you don't need to worry about flipping the sign, so k is just +8. So that would tell us that there is a vertical shift. Oh, sorry, let me write the number that's telling me this here. So k equals +8 tells me there's a vertical shift 8 units up. Okay, so in this parabola, there are 4 things happening, right? The parabola is opening down. Sometimes you will hear this referred to as a reflection over the x-axis. So again, depending on like your teacher and what they would like you to communicate, especially in grade 11, you might refer to it as that. In this case, it's okay for you just to say the parabola opens down. I know that means there's a reflection over the x-axis, but that's kind of what's happening, right? Again, if you picture that red translucent reflective manipulative that you might have used in elementary school where you place it on your graph and see how a shape or whatever, a line might be, how it reflects over wherever the red object, I'm not sure what that is called, but you know what I'm talking about, wherever that thing is placed. If you were to place it on the x-axis, then it's reflecting that y equals x squared, the parent function, it's reflecting it over the x-axis. Okay, so that's what's happening there. So it's opening down. There's a vertical stretch by a factor of 2. Again, we don't need to say -2, even though my a value is -2, because we already addressed the negative with the direction of opening. Your x lies, so this is not -3, this is +3, which is a horizontal shift 3 units to the right. Okay, positive means we're going right. And then your k value is +8, so it's a vertical shift going 8 units up. Okay, so that's how we can tell what the transformations are that are happening to our parabola based on the vertex form of the equation.